shadowed region toward the center of the imagery. That is Cabeus, with the crater rim and the mountainous region there on the top, causing a shadow that spreads over a portion of the crater floor. The Centaur will be targeting that shadowed region where we suspect ice is most likely to reside. With the image that's being shown now, you'll see kind of the central large crater there with a small crater at its top. The Centaur is expected to impact on the left part of the larger shadow.
Flight, 2 minutes to Centaur impact, and we are 1 minute to start of MBM sequence 2 and payload flash mode.
The shadowed region to the bottom left of that small crater on the rim of Cabeus is our targeted impact point. Rusty Hunt, the flight director, announced earlier that NVM sequence 2 would be running soon. That is the flash sequence, the beginning of the science sampling sequence that governs the remainder of the observation.
All stations flight mark, 60 seconds to Centaur impact. We start of NVM sequence 2.
We've just started sequence 2. This is flash mode now. This will run from 1 minute prior to impact.
Flight payload confirm sequence 2 start.
Through 3 seconds after the expected impact. We'll then switch to curtain mode, which will last for 3 minutes, and then the final minute before the shepherding spacecraft impact will be called
Flight,
crater mode.
This is science. Please change NIR 1 to OPR 9. Over.
Copy NIR 1 to OPR 9. Command flight, set it up.
Is that November or Mike? November.
Science flight confirm that's November.
November.
IR.
We are, the science team is now communicating to the flight team to adjust some camera levels.
Science flight confirm near infrared, November, correct?
On
confirm.
Near infrared camera.
Send NIR 1 to OPR 9.
Copy. Sending command.
All stations flight, mark Centaur impact.
That was an announcement by the flight director that the center impact should have...
Flight payload confirm receipt of command, over. Flight payload curtain start, over.
Copy that, payload.
We should be looking for some signs of the impact on the leftmost part of the...
Standing by with mid-infrared changes.
The left side of the shadow, right below the dimpled crater on the larger crater rim.
Flight, this is science. Make the rate changes. MIR 1, 1 hertz. MIR 2, 0.1 hertz. Over.
Copy science command flight, MIR 1 to 1 hertz.
Sending MIR 1 at 1 hertz.
And the science team is directing the flight team to adjust the sampling rate of some of the instruments to fit within the 1 megahertz.
Ready with MIR 2 at 0.2, 0.1.
The 1 megahertz signal limit.
Go flight.
Command flight, send MIR 2, 0.1 hertz.
MIR2, 0.1 hertz, sending command.
Flight confirm receipt of command, over.
Copy that, payload. All stations, flight 1 minute to transition to DV mode.
Transition to DV mode, which is Delta V mode, actually is a control mode for the spacecraft. It allows us to slew much more quickly, to continue pointing at this suspected Centaur impact point, even though the shepherding spacecraft will be impacting a couple of kilometers away. This is the last minute before the shepherding spacecraft also impacts the surface of the moon, and the last minutes of flight. We're watching the remaining few seconds of the LCROSS mission as we approach very rapidly the surface of the Cabeus crater.
Mark, transition to DV mode.
Flight
Payload confirm crater
NIR2 OPR change request. NIR2 to OPR 10. Over.
Is that November?
Copy. NIR2 to OPR
Yes, confirmed.
10.
November.
Ready?
Command flight send November IR2 to OPR 10.
Command sent.
Flight payload confirm receipt of command.
Copy, payload.
These are
Stand by for shepherding spacecraft impact.
the very last seconds of the shepherding spacecraft trajectory as it approaches the lunar surface. We are seeing very small craters within the crater.
We confirm a thermal signature of the crater in our mid-IR cameras. Over.
Copy, science.
We just
All
received
flight shepherding spacecraft impact. Stations report LOS.
the ground stations at Goldstone just reported a
Last packet,
termination of
11:35:054 seconds.
The shepherding spacecraft has hit the surface of the moon, and this marks the end of the LCROSS flight mission.
Okay, all stations flight. Great job. First step 179, complete closeout of your flight products and get them on MDPS.
Well, Michael, I wonder if you could give us your impressions of what we just saw and mission success.
Well, it's hard to tell what we saw there. I'm not sure. I'm not sure if the gain was set or correctly or what. We had some confirmation from the mock that they did have a thermal signature.
Yeah.
I should mention that the 9 instruments on the trailing spacecraft, the LCROSS spacecraft, were exercised on the way to the moon. In fact, we took images on the way and images of the Earth, so we're confident the instruments performed as expected. At the time of the impacts, the mothership, the Lunar Reconnaissance Orbiter, our sister ship, I should say, was about 50 kilometers overhead. They will have their first, and so they should have been seeing this with their suite of instruments. They do their first data downlink in about 2 hours or so. So we hope to have the data, and I expect we will be receiving both imaging data and spectroscopic data from the host of ground-based observatories probably within the next few hours. I think it is fair to say that within this $79 million cost cap, as I mentioned earlier, the experiment had been optimized to produce the largest possible impact plume. And so I remain confident that this is our best opportunity to date to measure the extent of water ice on the moon.
So what we're seeing here is a replay of that impact. Let's watch it for a little bit.
Yeah, even though there were 9 instruments on the trailing LCROSS spacecraft, which you see going in here, they basically break into 3 categories. There was something called a flash radiometer, which should have seen the flash, and by virtue of analyzing that signal, we can make some inferences about the depth of the regolith and it's the makeup of the dirt, as it were, that was thrown up by the Centaur impact.
Right, so brighter flash means, you know, it hit rock, and dimmer means it hit dirt, essentially.
Right, and actually you would want a dim flash here because that is suggestive that you hit sandy material and you want to throw up as much of that as possible, and that's easier to throw up than boulders. Then there's a suite of cameras, visible, near-infrared, mid-infrared, that provide information once we analyze the signal, once we analyze the data on the shape of the ejecta cloud, which contains both regolith and hopefully water vapor. It tells us about the dust grain properties in the ejecta